Assalamualaikum warahmatullahi wabarakatuh and very good morning. We are from group 3 and today we will explain on experiment 3 application of first and second law of thermodynamics. Let me introduce my group member. The first one is Ko Shui, Ko Meli, me, Nur Nadia Usna binti Muhammad Daud, Nur Kamilia Arisha binti Amrul Afridi, and Lai Yongwei. Date of this experiment on 20 December 2020 and our lecturer name is Dr. Shahril bin Hashim and we are from section 4. We will begin this part with introduction of this experiment. Okay, the thermodynamic can be defined as the science of energy. It means that energy can be viewed as the ability to cause changes. One of the most fundamental law of nature is the conservation of energy principle, or also known as the first law of thermodynamics. The first law of thermodynamics states that during an interaction, energy can change from one form to another, but the total amount of energy remains constant. But energy cannot be created or destroyed. The first law of thermodynamics uses a basis for the calculation of heat transfer. It is also used to study the relationship among the various forms of energy and also energy interaction. So we can see the fundamental truth of thermodynamics in our daily life. For example, when a ball is thrown from a top of the building, the energy in the ball change from potential energy to kinetic energy to source energy and lastly to heat energy. For the second law of thermodynamics, it states that when a body interacts with another body at a lower temperature level, energy will flow spontaneously from a higher energy level area to a lower level energy area. This means that heat can only be transferred from a hotter area to a colder area, but not vice versa. As a result, some of the natural processes are irreversible. So the natural processes that involve energy transfer must have one direction only. This law can give a picture to us that entropy of an isolated system is always increases with the time. Entropy is the measure of the disorder or randomness of energy and matter in a system. So the second law of thermodynamics can be expressed into two statements. The first statement is Kelvin-Planck statement and second statement is the Clausius statement. For the Kelvin-Planck statement, it states that it is impossible for any device that operates on a cycle to receive heat from a single reservoir and produce a net amount of work. It means like no device can achieve 100% efficiency. For the Clausius statement, it states that it is impossible to construct a device that operates in a cycle and produce no effect other than the transfer of heat from a lower temperature body to a higher temperature body. It means that we need energy input to the system in order to transfer heat from a lower temperature to a higher temperature. From both of these statements, we can conclude that the Clausius statement is more suitable to explain this experiment because the statement states that the energy will be more prone to move from the higher density of energy to the lower density of energy without the need to make any works. For the theory, the first law of thermodynamics states that the change in internal energy is equal to the net heat transfer to the system minus the net work done by the system. So, the energy in is going to be same with the energy out. The formula enthalpy out, internal energy out minus internal energy in is equal to heat rate minus work done. In this experiment, we need to calculate the rate heat transferred. The formula is mass of the hot water times with the heat capacity times with the change in temperature of hot water plus with mass of the cold water times with heat capacity times with the change of temperature of the cold water is equal to 0.
The objective for the experiment is to apply the first and second law of thermodynamics in the various processes.
So the apparatus used in this experiment are hot plate, two different size of containers, weighing balance, thermometer, and stopwatch. So for the procedure, firstly, two different size of empty containers are weighed accurately using the weighing balance. Next, a little amount of cold water was filled into a large container and the mass of the cold water used was weighed and recorded. Then a certain amount of water was poured into a small container and its weight was taken and recorded. The water was then boiled at a range of 80 degrees Celsius to 90 degrees Celsius and considered as the hot water in this experiment. After that, the hot water container was placed inside the cold water container as depicted in figure 1. Lastly, the reading of both water temperature for every 1 minute until they reach the same temperature was recorded.
Next, I will explain the result and discussion of the experiment. First, the mass of hot water and cold water used are 185.33 grams and 763.73 grams, respectively. Table shows the data obtained from the experiment. A graph of water temperature against the time is plotted. As shown in the graph, the hot temperature decreased as time increased, whereas the cold temperature increased with time increased. Eventually, both temperature curves reach a constant temperature which is 38.5 degrees Celsius. The occurrence of constant temperature indicates a thermal equilibrium is achieved. Besides, we can observe that the temperature of hot water changes more rapidly in the beginning state as compared to cold temperature. This shows that there is a higher rate of energy transfer in the beginning state of the hot water. The purpose of this experiment is to apply first and second law of thermodynamics. Thus, we need to calculate the change of energy in the system. Firstly, we have calculated the temperature change for both hot and cold water, which is final temperature minus with the initial temperature. We get the temperature change in the hot temperature is negative 46.5 degrees Celsius, and in cold water is 10 degrees Celsius from the calculation. Next, we require to calculate the energy change in both hot and cold water. Energy change is equal to mass times specificity of capacity of water times with the change of temperature. By substituting the information to the equation, we can get the change of energy in hot water and cold water are negative 36.08 kilojoule and 31.98 kilojoule respectively. Lastly, the change of energy in the system is the sum of the change of energy in hot water and cold water, and the result that we get is negative 4.1 kilojoule of energy change in the system. Now, I will explain the result obtained from the calculation. The change of the temperature is actually related to the first law of thermodynamics, which states that energy neither be created nor destroyed, but can only transfer from one form to another. In the experiment, heat energy from the hot water is transferred to the cold water and surrounding. That is why there is temperature change for cold water from 28.5 degrees Celsius to 38.5 degrees Celsius, and for hot water from 85 degrees Celsius to 38.5 degrees Celsius, through there is no work done on the system.
Moreover, this experiment also along with the second law of thermodynamics as well as the closure statement, which states that it is impossible for heat to move by itself from a lower temperature reservoir to a higher temperature reservoir. From this experiment, heat is transferred from hot water to cold water and surrounding. This cannot be done reversely unless there is work done on the system. Hence, the direction of heat transferred should be from higher temperature body to a lower temperature body. From the calculation, the change of energy of the system is not equal to 0 but negative 4.1 kilojoule. The result obtained has deviates the first law of thermodynamics, The negative sign illustrates there is heat loss from the system to the surrounding during the experiment. Not all energy from the hot water is transferred to the cold water. These situations occur may due to some errors happen while conducting the experiment. The first possible error made is parallax error. This happens when our eyes do not perpendicular to the reading scale of the instruments while taking a reading. Furthermore, the in contact of the thermometer with the beaker may also result in giving a wrong values of the water temperature. Some precaution steps should be taken during the experiment to improve our data accuracy. Firstly, to avoid parallax error, our eyes must perpendicular to reading scale while reading the instruments. Next, the thermometer should not in contact with the beaker to avoid wrong reading measure. Besides, we should stir the water throughout the entire process to ensure an even heating or cooling process. Lastly, the beaker must immediately be transferred to the cold water once heating is done to minimize the heat loss to the surrounding.
In conclusion, from the results obtained in the experiment, it can be concluded that the first law and second law of thermodynamics are obeyed. The heat will transfer from the hot water to the cold water until the system achieves an equilibrium where both water temperature become the same. The increment and decrement in temperature of both hot and cold medium show that the energy is always conserved, and it can neither be created nor destroyed. Hence, the first law of thermodynamics is proven. The direction of heat transfer from hot medium to cold medium proves the second law of thermodynamics, which states that the process occurs in a certain direction, from a region with higher energy density to a lower energy density region. So, this is our references used in this report. The first one is thermodynamic and engineering approach. The second one is Closure statement. The third one is Kelvin-Planck statement. And the fourth one is about the introduction to chemical engineering thermodynamics. And the fifth one is about the elementary principles of chemical processes. And the last one is about the fundamentals of thermodynamics. And that's all for our presentation video. Thank you for watching.